The next thing in this section is I want to talk about is scatter plot, and scatter plot is something which is very crucial for you to understand, because it will lay down the foundation of the next level of analytics. Now when I say next level of analytics, I just want to talk about, so first thing first, let me just tell you what we are learning. We are learning a scatter plot here, and what this scatter plot is actually, it's a combination of two variables. So when I say two variables, let's understand a couple of things. Okay, so first thing first, let's say I am picking up the height and weight of some school students, right? So I've just picked up some students and I wanted to pick up their weight and their height, and I wanted to understand like how is their BMI, right? This is what I wanted to understand. So let's say if the weight of the student, right, and then these like kids are from standard 1 to standard 12th, and I wanted to pick up if the weight of them is say 30 kg and the height is, say I'm taking that in centimeters, so height is say 130 centimeter, just say for that matter, right? If the weight is 38, the height is some around 140 centimeters. If the weight is 42, then they are around 150 centimeters. If the weight is approximately 45, then they are around 155 centimeters. Somebody's weight is 46 and their height is 165 centimeters as well. Some people have got the weight of 55 kg, but their height is approximately 150. Now what exactly we want to understand from this diagram is that the two values which I have taken over here, they both are numerical in nature. So we have numerical values in nature, numerical values in nature, and these two values are numerical. So you can see that we have quantitative values out there. Okay, now what I want to do is I wanted to graph this. Now when you pass on one column data, so if you remember, we were taking like in order to create any graph for that matter, right, any graph, right, except the line charts, if you want to create any graph, you need to have at least two axes, right, you need to have two axes, right, which are required to create any graph. Now in the previous examples which we have seen for the previous graph, we had only one column of data, right, only one column of data, and other values were the representation of their frequencies, right? So like how many people have got the weight from 30 to 40 kgs, and then we say that there are 5 people who were the weight. Now this 5 is nothing but the frequency, or you can say the number of students. So this 5 is actually drawn from first column, so that was only one column data. However, the things are a little different over here, right? We have individual values and we have weight and height over here, right? Now when you talk about weight and height of the people, you wanted to plot this, and this is where we need scatter plot. Okay, so this is how we are going to understand this. Okay, so let's create a graph. Okay, I'm creating a graph over here, something like this, and on the top of it we have say height, HEIGHT, height of the people, and here we have weight of the people, and weight starts from say 25, right? Then we have 30, 35, 40, 45, 50, 55, 60, 65, 70, 75 as well, right? So I have multiple weights over here. So we just say 30, 35, or we can just include a little bit more space so that we can come up with our example. So this is 30, this is 35, this is 40, this is 45, this is 50, and we have 55, and we have 60. Okay, till So we'll keep it till here. And then we have the height of the people. So this is 100 centimeter. This is somewhere we have 120, like 110, sorry. And then we can have 120. Then you have 130. We'll say 140. This is 150, right? And this is 160. Now when you pass on the values over here, so we'll say for 30 kgs of weight we have a height of 130. So for 30 kgs of weight we have a height of 130, somewhere here. There is a point somewhere here. Then we have for 38 kgs of weight we have 140 height. So 38 will lie somewhere here, like it's just above, then 35, and then somewhere here, right? So we'll go next to it and we'll say height is 140, somewhere here, right? This will be the mark. Then we have 42, which is 150, somewhere around 150, somewhere around this, right? Then we have 45 is the weight, and then we have 155 is the height, somewhere here, right? And then we have 46, which is once, and then we have 165. So 46 is gonna lie somewhere here, and the weight is 165, somewhere here, right? And then we have 55, and then the weight is 150, somewhere here, right? Now similarly, if you just notice here, similarly we will have multiple values, like, so we will have this value like this, and if we plot all these values somewhere around this is how my scatter plot will look like. Okay, these are the points. Now this is how you can define the scatter plot. So you will get all multiple values, people will have different weights and different values. You can define all these values. Now how this each point is actually contributing over here in the table, so you can have multiple people over here, there are multiple people, just keep on having multiple weights, and then you can define like at some around 40, somewhere around 47, the height would be somewhere around this, right? This is how you will define. Okay, and if you notice, this is nothing but, so for 47 of weight, right, the height is somewhere around 117, and this act as a coordinate. So this is my x value and this is my y value. Okay, this is what we wanted to understand. So the two things which we want to understand over here, right? The one is that whenever we pass on this kind of data to our system, my system converts that into x-axis and y-axis, okay, automatically, and can create these kind of points for me. For every point this holds true, right? So for somebody who is around 150, 56 or 57 or 56 kind of weight will have a height of approximately 157. So coordinate what this point would be 57 158 or something, right? Whatever, right? So this is the coordinate, this will act as a coordinate. So this kind of graph is called scatter plot, a scatter plot. Okay, this kind of plot is called a scatter plot, and we want to use this scatter plot so that we can understand what my data is all about. Okay, it just gives you some kind of inferences. So this is something you need to understand. First thing first, scatter plot is always drawn between two numerical variables, and the second thing is that it creates a lot of dot points which are nothing but the representation of the whole data. So we can pick up all these things. Okay, now I want you to understand couple of things from this, right, and what that thing is all about. So let me just delete this, right? I wanted to delete this. Okay, I wanted to delete this, and I wanted to draw some attention, right? I want your attention over here, right? So I can see what is the benefit of it. I can see a pattern right over here, right? And this is also called as pattern discovery, right? And what this pattern discovery means, that I can simply see that if weight is increasing, height is also increasing. right? So there is also a slope which matters. So first thing first, I can find out the pattern, and the second thing is I can find out the slope. So in patterns we have multiple things. So first thing first is something called a slope. The third thing is called strength of this association. Strength of this association. And the third thing is called anything unusual feature. I will talk about all these things in a bit. Unusual features, and what are these unusual features? I'm going to talk about that. Okay, so I'm just going to remove this from the from the board, so that I can write multiple stuff, and I hope it is making sense to you, right? So you don't need this kind of graph. Okay, now what I want you to understand is that we wanted to pick up anything in this regard only. So we want to find out the pattern, and on the basis of pattern we wanted to find out if there is any unusual feature. So first thing first is linearity, right? In pattern, the major thing we wanted to understand is linearity. Okay, and linearity could be of like various types. So first thing first is linear. It could be a straight line relationship or like non-linear relationship. So we have linearity. This can be divided into linear, and it can be secondly divided into non-linear, and we'll talk about that in a bit. So over here, if you see the pattern of this data, right? The pattern in this data is something like this, right? Which means that it keeps on increasing over a period of time, right? Over a period of time, or with the more values, you will see that the pattern is increasing a lot. So if I just draw the pattern in this is how the pattern looks like. Okay, this is how the pattern of the points looks like, which means that my weight is increasing and my height of the students is also increasing. Okay, so this is something called as linear pattern, wherein I can represent the whole data with one line. Okay, there can be other stuff also, right? For example, there like what are those stuff which we are talking about? For example, the relationship is either can be explained. So there might be some other things, like for example, if you pick up points over here, I'll say let me just erase them. Let me just erase them and make you understand about this. Okay, so let's say these are the points, right? And I can just give you some idea about other points. For example, what I can think of is that we have some patterns which are decreasing over a period of time, right? Something like this. Now in this case I would say that I have a non-linear pattern, which means that the values are increasing and then later on it is decreasing. Okay, so I cannot decide whether that the weight, if the weight keeps on increasing, then height always keeps on increasing. I'm just to give you an example over here, right? So I can also say that my line will keep on declining over a period of time. So I would say this is a non-linear relationship, non-linear kind of relationship. Now in linear relationship, there are multiple patterns which you can find out. And what are those patterns? I'm going to just talk about that. Okay, so first thing first, let me just draw this. Let me just remove this. So patterns are not always they keep on increasing. So how do you define the patterns? So first thing first, how do you define the pattern? If you have one value, if you have x value over here and y value over here, and you are like showing the relationship, right? How would you show the relationship? If you will say that x is increasing and y is also increasing with respect to that, which means that I will get the data something like this, right? It just keeps on increasing like this, right? It just keeps on increasing. Okay, but we do not, this is not always true, right? So what are the other possibilities you get? If x is increasing, right, y is decreasing, which means that our coordinate will increase over this period of time, but y value keeps on decreasing. And how this would work? Something like this. You have patterns which keeps on increasing. Okay, now how I'll just give you another example for the same, right? For example, instead of height, you can say, that, okay, we can keep it weight, and then we can say mileage of a car, mileage of a car, right? If the weight of the car keeps on increasing, then the mileage keeps on decreasing over a period of time. Or you can say the petrol price keeps on increasing, then the number of sales of the car keeps on decreasing. So we can give multiple examples of this wherein x is increasing and y is decreasing, right? The other possibilities which I can have is x is decreasing and y is increasing, right? Wherein you will have another way, and then we have, like, we can simply say y is increasing, right? And we can have x is decreasing and y is also decreasing with that, right? So there can be multiple examples of x and y relationship. That this scatter plot gives you an exact idea about how x and y are moving with respect to each other. Now I'm going to give you, so this part is completed, like we understood, right, what is linear and non-linear relationship. If I have a pattern which is going like this, I can say it's a linear relationship. I can represent this whole phenomena with a line. If I have a pattern which is going something like this or something like this, I cannot represent this phenomena with a line, then probably I can say that it's a non-linear relationship. The second thing I wanted to talk about is slope of this pattern. Now what does that slope of the pattern mean, right? This is something which we need to understand. So what I'm going to do is I'm going to draw some diagrams for you so that you can have a clear-cut idea about what this slope of the pattern is. Let's say slope of the pattern is that I have one value which keeps on increasing like this, right? Keeps on increasing like this. Now if you see over here, the increment slope is very, very low. Increment slope is very, very low over here, which means that I can simply say that they are not moving with very high slope. X is increasing, y is increasing, but the slope is not that good. And the second slope is something like this. Okay, one value is going like this, which means that x is almost, if x value is increasing, almost y is increasing, like almost at the same pace, right? And the third kind of the representation of the data would be something like this. X is increasing. Now how would you identify this whole thing? I'm going to draw that diagram for you and then I'll make you understand. Now just think. Now I want you to look for this value. Okay, now just see, if x is going from this value over here to this value over here, right? Okay, so x is increasing from this value to this value, right? I will draw in this way. X is increasing from this value to this value. I'll take another example, probably this example. This is much better. So x is increasing from this value to this value, right? This one is the value at this point and this one is the value at this point. So the change we've got is from here to here, right? This is the change we have got. And the value of y corresponding to this. So the y value of this is here, and for this the y value is somewhere here. I would draw something like this, right? So the difference in y is somewhere here, right? So if I say the x value So the change in X is, it ranges from 44 to approximately 50, right, which is approximately, I can say, 6 unit change in X, right? And the Y, in Y we have got only 1 unit change. So delta X, right, change in X is equals to 6, whereas change in Y is equals to delta Y is equals to 1. Okay, now just think about this perspective. Okay, here, so we have let's say pick up this value. Okay, so over here I have a value over here, and I have another value, say I'll pick up this value over here, right? So this is something which I wanted to talk about. So if you notice here, the delta y value, right, delta y over here is from here to here. However, delta x is somewhere here to here, right? This is your delta x, right? So you can see that the y is increased a bit. Okay, now I'm going to delete all this stuff so that there will be no chaos over here. Now just think about this point, right, versus this point. Okay, change, let's say this point versus this point, right? Delta y is greater than delta x, or if I just pick up for that matter this point. Okay, so this point over here is something here, and this point is something here. For this much of change in x, the y changes this much, right? So here you can see that for very small value of delta x, the y is increasing very high. So which means I can see that, you know, the slope is actually giving you that how x is changing with respect to each other. X is changing with respect to y, right? This is something which I wanted to make you understand. Okay, the second thing, right, the next thing which I wanted to understand is this strength. Okay, now what is this strength meaning? Okay, so I'm going to delete this completely. Let me just delete that. Okay, so let me just delete this, and I would like to give you an understanding of how things are changing over here. So let's delete this whole stuff. Now what does it mean to have a high slope, or the strength of the slope, right? So say one slope is something like this. One slope is something like this. Now what you can deduce from this slope? Now just think that for every change in x, there is not much change in y. There's not much change in y, which means that they are quite equal. Like for example, if I just simply pick up, I guess it's the best example which I wanted to pick up right now. Say instead of this mileage or these numbers over here, just let's keep that number same exactly as it is they are, and I wanted to just change this example. Something I would say this is square feet, and this is cost in 100,000, right? Now if you can see over here that if I change from 3,500,000 to 40,000 or something like 3,500,000 to 3,500 or something like that, like 3 point, like in India we pick up the lakhs, so you can say 35 lakhs and 40 lakhs over here. So 35 lakhs to 40 lakhs, you can see that we have got this much of variation in 35 to 40 lakhs, and for that there is a very consistent price. So in 35 lakhs, if I'm getting a flat of approximately say 1100 square feet and 1200, and just keep it square feet in terms of a square meter for that matter. If I'm getting a square feet 1100 square feet flat, probably in 40 lakhs I'll be getting very much closer to this, right? So I'm pretty sure that I will get approximately 11,050 or approximately 1160 square feet flat over here. I'm pretty much confident about that. There is not much variation in terms of the cost over here. However, if I have a slope which is going to be like this, something like this, something like this, something like this, okay, something like this over here. So you can see that we have a slope, right? And this slope is doing what? Slope, like, so for 35 lakhs, if I'm getting a flat of around something like 1050 square feet, right, for approximately 39 lakhs. For 45 lakhs, I'm getting one flat which is approximately 1050 square feet, and also for 45 lakhs I have got one more flat where I'm getting like approximately this flat, right, this flat over here, approximately I'm saying. So I'm not sure, right, I'm not sure about the relationship between x and y. Like in 4500 I am not sure. Now this is a weak relationship between x and y. This is very weak relationship in x and y, right? Because for 40 I'm not sure, like it is ranging from this area to this range, right? I can get a flat between like some 1050 square feet to 12,070 square feet. I'm not sure. However, in the previous example I was pretty sure that I'll be getting close to that, right? So this is something which is defined as the strength of the relationship of any particular the relationship like which we are trying to draw from this, right? So whatever conclusion we are trying to draw from this, okay? So this is something which we need to understand, okay? Now there is something called unusual feature. Now what is that unusual feature, right? Unusual feature means that I wanted to talk about something which is not, I mean, if I say like not usual, probably it will, I mean the same thing, but eventually which is not falling in the trend. Now what is that thing which I wanted to talk about which is not falling in the trend? Is that I have mostly flats lying in the same category. However, for same 45 lakh rupees cost, I'm getting one flat which is 1600 square feet. Now this is an unusual feature over here. Why this is an unusual feature? Because most of the time if I spend 45 lakhs I get a flat close to 1300 square feet, but this is an unusual feature. I call this as an outlier of the data, right? So first thing first, when you create the scatter plot, how do you read that scatter plot? On the basis of pattern, on the basis of slope, on the basis of strength, and on the basis of unusual feature, if you have any unusual feature. So your analysis depends upon these four different factors. Now this slope, can this slope be negative or close to zero? Is it possible? Slope is nothing but the values of x and y, like how they're changing with respect to each other. Yes, it can, right? And how it can vary, right? This is something which we want to see, right? So what I'm going to do is I'm going to delete this whole stuff, right? And I wanted to draw some patterns for you, okay? And I want you to understand this pattern. This is the positive pattern which I've shown you, right, as like just now. The negative pattern will be something like this. This is where my slope will be negative. I would not be able to get a positive slope, which means that x is increasing, y is decreasing, right? Now do we have any other slope which is possible? Yes. And what kind of slope that would be? Something like this, something like this. Do we have a slope? Yes, but the slope value is 0. When the slope value is 0, which means that I can define this data like probably by creating a line like this, okay? So virtually there is no slope. M over here is 0 over here, and if m is 0, probably I will say there is no relationship, or there is not significant relationship between x and y. Now there could be another kind of possibility when you deal with this kind of data, and that is when you have y value which is constant, which is completely constant with respect to x. So if all the values are going like this, which means that y remains constant no matter what the value of x is. Okay, and this is where you say that y and x has got no relationship or zero relationship with each other, right? The other possibilities would be, let me just delete this. So other possibilities would be when you have for all values of, for x value remains constant and y something like this, then there is no relationship, right? Y keeps on increasing for every value of it. There is no relationship between x and y, which means that y is not dependent on x in order to change something. So this is how you read scatter plots, and I want you to understand and absorb this complete pattern, because there might be like n number of instances. Now there will be some other unusual pattern which you will get when you deal with scatter plot, and I'm going to cover that up, right? And this is a very special case which you get, and there is a different way to deal with this kind of scenarios once you get it. I'm going to talk about that pattern. Okay, so I'm just deleting this so I can show you that pattern, and that pattern is called clustering. Okay, that pattern is called clustering, and how this clustering works. So you have some groups of relationship over here, then you have another relationship over here, right? And then you have another relationship over here. This is not at all correlated data. This is not, which means that x and y are not related to each other. However, they are forming a cluster kind of thing. So you will also say that this is very unusual kind of thing. However, if you see somehow, if you see some patterns, right, which are something like this, you need to be suspicious, right, for that, for in case like you get this kind of data, right? And what is this pace of suspiciousness? I'm just going to talk about that. So if you get some clusters over here like this, right, and then you get some clusters over here, right, and then you get some clusters over here, which means that it shows a positive relationship, but even though it is showing a positive relationship, these values are unusual in nature, right? So I hope it is making sense, like what this scatter plot is all about. So remember that that histograms, dot plots, box plots, scatter plots, and bar plots, these are the main the graphs for any kind of data analytics, and you use them like anything in any kind of data analytics. Okay, so I hope it is making sense for you. We wanted to talk about something more in this pattern as well, right? Which means that I just wanted to lay down the foundation of it. Okay, and the foundation which I wanted to lay down is that that pattern is something which you can sense, right? Whether it is linear or non-linear, right? Slope is a mathematical term, right? So you need to have a mathematical entity for the slope, mathematical entity, which means that how would you tell like what is the slope like? So I shown you three slopes, right? One slope is this, other slope is this, other slope is this, right? So this is my slope 1, this is my slope 2, and this is my slope 3, which is, these all are different slopes altogether, right? They are that all different slope. There has to be a mathematical entity which will define how this slope is varying, how this slope is defining x and y relationship. There is a second thing which I wanted to talk about is strength of the relationship, right? Whether you have a graph which is going like this, or you have a graph which is going like this, it is also increasing graph. So there has to be a mathematical entity which will define the strength of the graphs. And the third is unusual feature. This unusual feature also creates a lot of problems when doing analytics. So we need to learn to deal with this kind of unusual features in the data. So in upcoming videos, we will also talk about the mathematical entity of slope, strength, and unusual features. Stay tuned. I'll see you in the next video where we'll talk more on the regression plot, on this scatter plots. See you next.